Radial patterning of the embryo. What is radial patterning? It is a circular pattern around the central axis, which we can easily see here in the kiwi. We have the middle, and we have around it, we start to see this pattern that's going around in a circle. And that essentially is radial patterning. You might think that radial patterning is only used as a defense mechanism in animals or as nature's beauty in the fruits and flowers. But there is radial patterning in the embryo early in its development. This process starts after fertilization, when the embryo is divided into two ends, the apical and the basal. The embryo will continue to divide, and we will start to see radial patterning in the globular stage. Periclinal division will create the three primary layers: the protoderm, which develops into the epidermis, the ground layer, the structure of the plant, and the procambium will differentiate into the vascular tissue.
Regarding mutations that affect radial patterning, we have scarecrow and shortroot mutations that have noticeable effects on radial patterning. In the wild typing of these genes, they both function in the establishment and maintenance of the radial pattern during and after embryogenesis. They are both necessary for tissue and cell differentiation in the embryo, primary roots, secondary roots, and the hypocotyl. Both mutants were identified through isolating roots that were growing slower than the wild type, and both mutants had roots with a single cell layer of ground tissue. In the scarecrow mutant single cell layer, there were cells that were not uniform, with cell characteristics of endodermal and cortical cells. In the single cell layer of the shortroot mutants, there were only cortical cells, without any endodermal characteristics present.
During embryogenesis, radial patterning begins to organize cells by their function through asymmetric division. Radial patterning remains an important characteristic of plants that ensures the successful development of the three tissue systems: the epidermal, the ground tissue, and the vascular system. Each of these are controlled by a separate primary meristem. The distinct patterning of these tissue systems is to regionally specialize plant cells based on their function, such as providing protection, providing structure, with the transportation of water and nutrients. These precisely arranged regions optimize adaptations to environmental conditions, such as drought, temperature, or poor nutrient soils.